Hey everybody, today I'm going to be talking about the 10 deadly sins of SQL Server configuration, the untold stories of a pen test monkey. This is a presentation recently given at AppSec, California, which was a lot of fun to give, and so I thought I'd put it online for those who weren't able to attend. My name is Scott Sutherland. I'm a network and application penetration tester who works at NetSpy. It's a company out of Minneapolis. I have done some previous work around databases and other penetration testing topics. You can go check it out at all of those fun locations. During a lot of the penetration tests that I've done, I've had a lot of fun and interesting projects involved on the network layer and on all kinds of applications, from mobile to thick app to web, of course. But they all cross over the database layer at some point. And it seems to be one of those spots where a lot of development groups don't have as much deep knowledge. And so that's why I thought I'd put together this presentation to provide some insight into some of the misconfigurations that we're seeing during application and network pen tests that actually give us the ability to get access to data and systems. So it's really shining some light on what happens after an attacker gets credentials to the database, or what happens after SQL injection beyond minimal data access. So first I'm going to cover off on, really briefly, why security breaks generally speaking. Same with where it breaks in SQL Server that we see the most of. Get into some security basics for SQL Server for those of you who are not as familiar with the language. Talk a little bit about finding SQL servers in your environment, and then dive into the main 10 attacks and reconfigurations that we see. So why does security break? Generally speaking, developers have a lot on their plate, and they have a ton of requirements out of the gate, for any project. Usually it's on a very tight timeline. And so what ends up happening is they don't have enough time to basically go out and dig into all the nuance of every database platform that their app might be interacting with. So the downside here is that in some ways they're expected to essentially be a DBA, and in some cases that extends to DevOps and IT admins, but they aren't. There's DBAs are basically a whole other career line, and people spend years and years and years trying to understand these complex database platforms, and developers just don't have time to kind of match that depth of knowledge. And it's no strike against them. It's just a reality of the business. So that obviously contributes to a little bit of security fail. Where we see that happening the most in SQL Server are at points of integration and trust. So when an application connects to a backend database, once in a while that application database will want to, or have some requirements to, reach out to the operating system, reach out to another server, et cetera, et cetera. And it's when we're reaching beyond the boundaries of the database that security risk starts to become introduced. And so in order to facilitate reaching out across these trust boundaries, we do things like cache authentication or credentials. We do things like give users the rights to impersonate other users through various methods. And we assign excessive privilege all over the place. And so these are kind of the general categories that I'll be talking about in a little bit. But before we do that, I want to talk a little bit about SQL Server security, the very basics, just to get some language down so people understand some core concepts. First of all, I'm going to talk about SQL Server and what it is. At the end of the day, it's just software that runs as a Windows service. Each installation of SQL Server is referred to as an instance, and you can have more than one installed. That means there's more than one Windows service running in the background. And each of those services will run with the privilege of the service account, which is a defined Windows account, which can be in many different accounts, which can have a huge effect on security, which we'll talk about a little later. So here's kind of a diagram of that relationship of those objects. So we have the Windows operating system. Within the Windows operating system, we can have multiple SQL Server instances installed. Once again, those run as Windows services. And then within that, we have individual databases with different access controls, and then tables that hold all of the application data. Now, to get access to those, we have what are called security principles that work on different levels. We have operating system and domain accounts and groups that we can use. We have SQL Server's logins that exist only within SQL Server. And then we have database level users. The Windows accounts and the SQL Server logins are used to actually just get into SQL Server to connect to the server to determine, now from here, can I get access to different databases? In order for any of those logins to actually get access to a database, though, a database user has to be created in the database and then mapped to the user, which can be a little bit confusing. I know it was for me. So I tried to draw out a little diagram to help myself and others understand kind of how these relationships work. If, once again, we have our Windows operating system, we have our installation of SQL Server in the green box, and then if we start kind of at the left, we can see the native SQL Server login, my user 1, wants to get access to data within database 1. And in order to do that, we actually have to create a whole separate database user security principal. Typically, it's named the same as the login, and then map those together. So then once the my user 1 logs into the database server, it will be mapped successfully to the database user, which can then be provided access to the tables to different access controls and privileges. Windows security principles work very similarly. There's just one extra step. So you can provide local Windows accounts or domain accounts access to your SQL Server. And the way that works is that's mapped to basically an SQL login with the same name, which then is typically mapped to a database user with the same name to provide access to that data. There are also a few roles that are kind of important to be aware of. A sysadmin within SQL Server means a DBA, basically, so you can do anything in the database. There's also a public role, which means everyone pretty much who has the ability to connect to SQL Server. And those are at that server level. Within the database level, which is this orange box that we see here, there are some things to be aware of too. The database owner is the actual login that creates the database. So technically they own it because they created it. They can transfer ownership, but very often they don't. We'll see why that's bad in a little bit. And then we also have the DB owner role. So the person who owns the database can basically delegate management of that database to another login or another user, database user, and that's what that's for. So we'll talk about some of the risks that are involved with that relationship in a little while. But first, let's talk about finding SQL servers in your environment. You want to go out, you want to lock down all of these servers. Helps to know where they are. There are a few methods that we use during pen tests and that a lot of white hats or internal security teams use as well. The first is simply just scanning subnets for databases. Doing simple port scans against SQL Server is no longer really an effective method of finding all of your database servers. So using a more modern scanner is going to be the route you want to take. We'll use UDP scans that will allow you to identify the instances and the associated ports and things like that, which might not be 1433. Although we still see that a lot. 1433 is the default, or has historically been the default port for SQL Server, but that has kind of changed over time. So don't rely on that solely. The second method, which is pretty effective, it will get you the majority of the SQL servers in your environment, is using something called service principal names. So every time an SQL server is installed on a domain system, it registers with Active Directory, which is kind of the central authentication mechanism in most Windows environments. And so that's registered with the computer account that's in AD or Active Directory. And what's interesting is that any user in the domain can go query Active Directory for a list of those SQL servers. And the reason they're able to do that is because it's there to facilitate Kerberos authentication. So if it wasn't there, we couldn't use Kerberos authentication to authenticate to these SQL servers. But aside from authentication, it's just a really good method for dumping out a big list of all of the SQL servers installed on your environment, or I should say most, as I have underlined on this slide, because people can go back and change the service accounts for SQL Server later, and so some of the information may be false. Or an SQL Server instance might be installed on the system, and then the system's added to the domain, and so it might not be included. So there are some niche cases where it's not going to be showing up. There are a few tools out there. SetSPN's a native tool that comes with Windows 7 and later, I think. ADFind is part of a tool kit called called JoeWare by Joe Richards, I think is his last name. Very neat Active Directory toolkit, been around for a long time, incredibly useful. And then I put together a really kind of quick get spn.psm1 module. It's a PowerShell module for basically searching for service principal name types and users and things like that. So you can go download that from the GitHub that I listed earlier in the pre-zone if you're interested. All right, so let's move on to the fun stuff. So these are the 10 deadly configurations. I know I say configurations, but this talk really is intended to be targeted at not just pen testers, not just IT admins, but DevOps guys who are responsible for writing secure code, and also implementing it on the servers. So some of these are more traditional SQL kind of configuration tweaks, and some of them are code recommendations, most of which should be intuitive to people who've been coding a while, but for people who are newer to it or kind of out of their comfort zone, it should be good information. All right, so here they are. They're not in any great order. I will be covering off on ways to go, escalate your privileges to a sysadmin from login. I'll talk about getting sysadmin rights using kind of database user privilege issues. We'll talk about service account privilege issues and different types of impersonation, all the way down to some of the transport level encryption stuff. But generally speaking, these numbers aren't a reflection of how often we see them, although I'll try to speak to that as I go through. Funny enough, logins that are configured with sysadmin privileges that don't need to be are really probably the #1 issue. So coincidentally, this is #1. It's pretty easy to understand what happens in a lot of environments. Maybe half the environments we come into are the application, whether it's a stick app or web app or whatever, it's set up to use either the SA account to connect to the SQL Server database, which is a sysadmin, so that's the DBA once again, or the application connects with a different sysadmin. So long story short, they're connecting as DBA, which gives the app user a ton of privilege they don't need for the application to function and creates a lot of risk. So this is bad because obviously now I can get access to not just my applications database, but other application databases that are unrelated. I can often get access to Windows directly and execute arbitrary commands. And this is compounded because there's a ton of tools out there for attacking this. The ones that we see publicized the most are probably the Metasploit modules that have been around for quite a while now. One that I have, or the first one I have listed there is the MSSQL payload module. So if you provide username and password, you can connect and basically get a shell on the system or interactive console running a system or greater, whatever. And then the other one can be executed via a previously identified SQL injection. As an attacker, if I'm coming at this, the requirements here are I just need to find the connection. So if it's SQL injection, I'm already a sysadmin. If I'm coming in with credentials, it means as an attacker, I probably already grabbed them from, say, an unencrypted web.config or source code or something like that that got me into the database level. So the nice thing is it's really easy to fix. I mean, long story short, don't provide your application database accounts or logins with sysadmin privileges, and only assign what are needed for the app to function. That should be pretty intuitive. Now, I know a lot of dev teams will go and they'll say, okay, I removed all of my sysadmin privileges, but I still needed my application to access some objects that are maybe outside of my database. So I gave my application user the impersonate privilege. And impersonate privilege is exactly what it sounds like. It allows you to impersonate another login without providing any credentials, which isn't exactly how the function or the privilege was intended to be used. As far as I can tell from the Microsoft documentation, it really was intended to decrease privileges. So if I'm a sysadmin and I'm carving out some new accounts for an application, I want to make sure that those accounts function as expected. And so the impersonate privilege might be used to go down or laterally move your privileges between users and the application. It's usually not intended to go up, as far as I can tell. Anyways, it's often used to increase privileges, and the interesting thing is you can just do it whenever you want. If you have the privilege, you can on-demand impersonate the users that you've been given privileges to impersonate. which I guess is pretty intuitive, but a lot of people aren't aware of it, and so, you know, historically it's been one of those things that's potentially been missed on pen tests, but over the course of the last few years, it's one that we've been picking up a little bit more. The attack requirements for this one are, once again, some type of connection to the database, right? SQL injection, direct connection, also, the login has privileges to impersonate another user, and as I mentioned before, if they have privileges to impersonate a sysadmin, well, then they can inherit those privileges. And in some cases, that can be the first step to becoming a sysadmin. So say I can impersonate a database owner or a database user who has the DB owner role, like we talked about in the intro. There are some steps that can be taken there to escalate. So most of these attacks I'm talking about can be chained together in really creative, scary ways. But let's take a deeper dive into this impersonate privilege. So it's pretty easy to check out what logins you're able to actually impersonate. This does, I should mention, work on the database levels too. So you can impersonate logins and database users, but we're just focusing on the logins for now. So in this particular scenario, I can impersonate 2 users and the SA account, and then go look into what privileges they have. So as an attacker, this is just a quick example in Management Studio. But as an attacker, I could come in, check out what privileges I have. Okay, I'm my user, I'm not a sysadmin, so not a DBA, but I just saw that I have the rights to actually impersonate the SA account. So I go ahead and execute this one line of code, very easy TSQL, execute as login equals SA, and we can see when I run the kind of identification commands here, giving me the list of what user I am and whether I'm a sysadmin or not. We can now see I am SA, and I also have verified that I am running with sysadmin privileges. So it's a very quick escalation if you know what you're looking for. So to automate this a little bit, I created 3 different scripts, 1 in PowerShell, 2 in Metasploit, and you're going to see a pattern. I have kind of done this for a handful of the scenarios that I have on this list. So the goal here is to give you some flexibility. If you don't like Metasploit, you can use PowerShell, or if you want to exploit it through SQLi, you can do that. And also note that the SQL injection modules I've written only work with error-based SQL injection, so it's something that has to basically return some type of error message to the page when you initiate the attack. The only module that has blind injection enabled and kind of select-based injection or union-based injection is the SQL link crawler module, and that piece was actually written by Antti Rantasari, who also works at NetSpy and has a lot of great blogs out on netspy.com, so check those out if you're interested. Anyways, here are a couple screenshots of this in action, but I did also put together a video, so let's give it a shot here. So I've already pre-configured this. The main point to make here is that any of these SQL injection modules, you have to know the injection point ahead of time. So burp, manual discovery, however, SQL map, however you're going to find it, go find it, and then you can pump that into this module for escalation. First, the module will go out, it finds the users you can impersonate, then it checks if any of those users are actually a sysadmin. And if they are a sysadmin, it'll actually make your current user a sysadmin. So it'll impersonate a sysadmin and basically add your user to the sysadmin group. So how do we fix this? Don't use the impersonate privilege to access external resources. It's pretty much that simple. I know that there are going to be some scenarios you need to access external data, and I've kind of outlined a method a little further down that has to do with signing store procedures with certs, and so I'll get into that a little bit later. But generally speaking, if you need access to some external object that's considered privileged, use the cert signing. It's the best way to apply granular access control. And it seems to be the method kind of supported by Microsoft. So that also helps from a documentation perspective. So, excuse me. Next we have number 3, database users with excessive privileges. This is, once again, now we're moving into that database level, moving away from the login. So at this point, someone has a login, and now we're talking about what privileges they've been signed or mapped to within the database. And what we see during some of our pen tests is that the database account being used by the application is either provided the DB owner role or has been provided the rights to create stored procedures within the database. And that by itself isn't insanely horrible. It's not bad, especially if that user was intended to have read-write access to all the tables in the database. However, it becomes a problem because you have the ability to execute as the owner. And there's a clause you can basically insert into your stored procedure. And when I say the owner, I don't mean the owner of the stored procedure, I mean the owner of the database. So if a sysadmin or a DBA creates your application database and never changes the owner before it goes into production, if a database user can actually create a stored procedure, they can execute the privileges of a sysadmin. So to make that a little clearer here, I've outlined the requirements. So from an attacker's perspective, you would need that connection. SQL injection works fine. Direct connection's fine. You need the database user to create the procedures. The sysadmin has to own the database. And the last condition is the database has to be flagged as trustworthy. And by flagging a database as trustworthy, you're basically saying everybody in the entire SQL Server instance can trust this and allow it to access different data, interact with the operating system with a higher level of privilege and things like that. So here's my example of an evil stored procedure that you might create if you happen to be an attacker who, say, found SQL injection in an app, and now you want to become a sysadmin. After identifying a database that is owned by sysadmin that you have the rights to actually create a procedure in, you can create the SP escalate me procedure, and the key thing to pay attention to is what I just highlighted, which is the with execute owner. So when this procedure runs, it will execute as a sysadmin. And so if we look down at the code in the stored procedure, there's a very simple call to add us, the my app user is the user I'm connected with, to add us to the sysadmin group. And at that point, I have full control over the database server. So it's basically 2 moves to sysadmin. So once again, number of different scripts. Go check them out if you're interested. PowerShell makes, pretty screenshots. So does Metasploit. But I'll give you a quick demo video here. So this is an example of a direct connection instead of a SQL injection. So you will have to put the connection information in, the IP, the port, username, and password. And you do have the option in Metasploit to add Windows authentication, domain and local. You don't have to use it. But anyways, the module will go through. It will look for trusted databases that are owned by sysadmin. It will verify that you have the rights to basically create stored procedures, namely as a DB owner, and then add you to the sysadmin group similar to the last module. So pretty easy to use. Generally, the fix here is don't provide database users with privileges to create stored procedures if you don't have to. Don't allow sysadmins to own application databases, so you can have a separate application account that's an owner, the official owner, and then you can have a application account with less privilege to interact with it as it normally would. And then don't flag the database as trustworthy if you don't have to. There's a lot of methods that you can use that will help you avoid this. All right, so number 4 is one of those instances I was talking about before where it's sort of a configuration, but it's really about code. In this instance, when I'm talking about SQL injection, I'm not talking about SQL injection in your app. I'm not using dynamic SQL like in .NET. I'm talking about it actually in native SQL stored procedures. So the issue, as I kind of just mentioned, was we keep finding stored procedures that have dynamic SQL that's not being used securely. And then in some cases, those stored procedures are actually configured in such a way that they're going to run as an elevated user or a sysadmin or some other type of elevated privilege. So this can be obviously turned into SQL injection. It will allow someone to run arbitrary queries through the stored procedure, which can be bad, especially if you're trying to lock down functionality. And like I said, it can be used to escalate privileges under certain circumstances, which I'll touch on in a sec. The biggest thing with the SQL injection is that most people aren't using parameterized queries, and they're concatenating strings, which is really, really bad. And I'll show an example of why that's bad. For those who don't know, there are the two main scenarios that I've been able to identify during pen tests that would allow you to actually escalate privilege through the stored procedure SQL injection have to do with, once again, that with execute as clause that we just leveraged to escalate as the DB owner role. So in some cases, a developer might create a stored procedure to execute as the owner. And so if we have SQL injection, that means that we can run whatever we want as the owner, which may or may not be sysadmin. But as we mentioned before, the database does have to be trusted for you to be able to access objects outside of your current database. On the flip side, the other alternative that I do reinforce is using signed certificates, so that when you run the stored procedure, it will run with the privileges of the cert user or the certificate it's been signed with. That does not require that the database be trusted for it to be able to kind of reach beyond the database. But it is still probably the most secure solution if you're using secure coding practices. So anyways, I thought I'd give a really brief example here of going out and looking to find signed stored procedures that have the dynamic SQL issues that I've been talking about. More details and full code examples are on the NetSpy blog. If you guys are interested, go check it out. So here, I've ran the query. In this case, I've run it as a sysadmin, and it actually returns a stored procedure. We can see that it's been signed by the SP SQL2 cert, and that has been bound to the SQL2 cert login. And then the privileges required are then assigned to the login. In this case, for the sake of the example, the login's been made as sysadmin. So it's worth noting really quick that as an attacker, it's going to be harder to get the list. As a white hat or developer being proactive about security, it's much easier to run these queries, find the stored procedures that have potential bugs, fix the bugs. As an attacker, if you can't read the source code of stored procedures in your database, it's going to be a little harder to find these. You're going to have to actually go through and try some of them out blindly, which can be dangerous, and I warn against a little bit because if you don't fully understand what the procedure does, you could be doing some damage to the system. So be careful if you're on the pen test side of that. But so let's just take a quick look at a bad procedure. So this is using the concatenated string that I talked about before. Super bad, don't do it. From an attacker perspective, this is what the injection looks like. We're basically on the far left there where the black color ends. We're more or less closing out our original statement, and then we're going to say, hey, please run this operating system command for us. And this is kind of what it looks like in the context of the full stored procedure. This is how it actually executes. So hopefully that sheds some light for people who care. Finally, this is what it looks like when we actually execute it, right? We inject our additional code in kind of the top pane there. We see the master database being returned as intended, and then we see the operating system command that we injected being returned back as well, basically saying the SQL Server service is running its local system. I only did one script for this. It basically will export all the stored procedures that you have access to and can read the source code for, and it will dump them in a file and parse out all the TSQL files for you, which can be kind of handy, or at least used as a backup system. I also added some flags that aren't shown in this screenshot that allow you to actually search for some of the dynamic SQL issues that I've been talking about. So, general lessons learned for this one: do use parameterized queries. Don't concatenate your strings in evil ways like we saw. Don't use execute as owner to access external resources, because typically you're going to be providing more privilege than the application really needs to function. And then don't flag the database as trustworthy if you don't need to, because it really does open up a lot more attacks. Trustworthy flag is not just for execute as owner. There's a number of different things like database chaining. That can be, or database ownership chaining, different object chaining. That can be, the trust can be weakened the second you enable that. So be careful with that. All right, so here's the list I promised you earlier. When you are signing stored procedures, this is kind of the high-level process you would use. You generate a certificate. In step 2, you generate a login for that cert. You then assign the required privileges to the login, and then you sign the procedure with the cert. So then that actual stored procedure will be able to access objects with the privilege of the login you created from the cert. So that can be a really effective way to kind of, once again, keep the permissions a little bit more granular. So a fixed version of the procedure we saw before would look something like this. We no longer see the execute as owner because it's signed by a cert. We no longer see the concatenated strings, and we're using parameterized queries. So now this executes safely without the risk of letting someone escalate privileges. Number 5 is one of my favorites. There are a ton of stored procedures that are accessible to that public role out of the box in SQL Server. And once again, the public role are all the users that can log into the server. So you might think that wasn't such a big idea, but there are quite a few stored procedures that can be used to do all kinds of interesting things. I didn't provide a full list today, but I did put together a list of 4, which are ones that we use a little bit more commonly during penetration tests. The first one is XP regread, which is an extended stored procedure, meaning it most likely interacts with the operating system. And so it gives you the ability to read registry keys, as you would guess. And it can do that with the privilege of the service account. So if your service account running that Windows service on the background, right, on your operating system, is configured with least privilege, this might not be a big deal. But what we see in a ton of environments is that service account is configured with excessive privilege. And so that would allow you to, say, read every single registry key. And so far, we haven't been blocked reading anything, especially if we're running as local system, which is about half the instances we see during pen tests. But the one constraint we have had is trying to read certs or private keys out of the registry. They end up getting truncated. So if anyone knows how to read private keys out of the registry with SQL Server, please let me know. I would love to know. But I'll let that one go. The next one here is XP directory. So this is a function that's intended to let you basically recursively list directories on your current SQL server, but it also supports UNC path, which means I can attempt to list directories for remote file servers. So what that means is I can force SQL Server's service account to authenticate to me. I can capture its password hash, and then I can do a number of things, one of which would be crack it. And at this point, there's a guy named Carl Fossen who works on our team as well, and him and Eric Gruber have a pretty good series of blogs on building cracking boxes. And so they build us a nice one that can basically crack approximately 35 billion net NTLM v2 hashes a second. So usually during a pen test, when we initiate that connection, capture the hash, I mean it's literally a couple seconds before we end up getting the password and being able to log into the server. So we'll talk more about that a little later. But huge impact for that one. The next two are more interesting during network penetration tests. By default, as a SQL Server user, you're not allowed to access the functions or tables that list out all the logins for the server. You also don't have the ability to list out all the domain object information that the SQL Server is installed on. But with these two functions, the suser name and suser sname, we have the ability to query that information or essentially brute force that information as a login with only the public role. So the requirements for all of these are basically just public role access via SQL injection or direct connection. And I thought it might be fun to just go through the domain user enumeration scenario, walk through it manually, and then show you some of the automation. So the first thing we need to do from an attacker coming in blind, right? I don't know the domain of the SQL server, so I need to grab that first. Once I know the domain of the SQL server, I can then guess at what one of the domain objects would be. So for the reason that every installation of Active Directory has certain standard groups, one of those groups being the domain admins. And so with now this enumerated domain and the known group, I'm able to use this function called suser_sid, provide that basically domain object to the SQL server, and it goes out and queries Active Directory and gets the RID of the domain admins group. And so the RID is the unique identifier for that group object, for that object in AD, on the domain. And what I want out of this is I really want the domain SID, which is the unique identifier for the domain itself that the SQL server is installed on. And so luckily that happens to be the first 48 bytes, so I can just chop off the short piece of the RID, or the unique number associated with that domain admins group, to get SID. And then from there I want to basically fuzz out other objects, and so I'm going to start with 500 because that's where the default admin starts. I can convert that to hex, which is the F401, and then I need to pad that out to 8 bytes so it's all nice and clean and can be consumed well by the functions in SQL Server. And then I just concatenate those together, as you see at the bottom there. Now we have another full RID that I basically just guessed, right? And then I can push that new full RID into the suser sname function, and lo and behold, it pops back demo administrator. So I've now blindly enumerated the domain admin, one of the domain administrator accounts. Default administrator accounts for the domain system. So that's pretty powerful by itself, and this becomes really impactful when we start incrementing, right? So if I want to guess the next user or next object, I increment the number by 1, and then I repeat that like 10,000 or more times. Especially for larger environments, you're probably going to go over 10,000. And you're going to not only get the domain accounts, but you're also going to get domain groups and domain computers. And this is pretty impactful during a net pen, especially if it's an external pen test, because of dictionary attacks. So what we found is that once we have a full list of users, which is often in the thousands, we can test 1 or 2 very common passwords like season followed by the year, or password 1, or something like that. And we're going to get at least a handful of accounts that are configured with that. And from there, we can use common entry points like remote desktop, Outlook Web Access, VPN, that happens to be single factor, Citrix, all kinds of common externally facing interfaces that use integrated authentication with Active Directory to then gain a foothold in the environment and escalate to domain admin. So for those of you who aren't as familiar with network pen testing, it can be between 2 and 5 steps to domain admin. It's pretty operationalized. The industry as a whole is pretty aware of how to get from user to domain admin in very few steps. Number of accounts, a number of scripts listed here as well. And for both the SQL login enumeration and the Windows account enumeration. So I'll show the demo really quick of the Metasploit module. That's done through SQL injection, because that's probably the most useful to a pen tester who's not on the internal network. Once again, you do need to know the SQL injection point. So once you set that with the IP and the port, you're pretty good to go. You can also set the fuzz num, right? I did say make sure to set that up. That's going to be the number of RIDs you're going to fuzz. I have a smaller environment, so I knocked it down to 1200. But as it starts up here, we can see it grabs the server name, the domain name, the SID for the domain, all via SQL injection. And then it's going to start iterating through the RIDs like we talked about. So it's going to go through, we can see it's getting the administrator account, domain users. It's getting enterprise admin, the domain group. And it's getting computers. So anytime you see an account with a $sign after it, that means it's a computer account. You drop the $sign and that's the computer name internally, which is also valuable for identifying targets before you pivot it onto the internal network. All right, and then this also, I have it actually save out to a file, so you can just take this list of users and just shove it right into your dictionary attack tool for doing online dictionary attacks. All right, generally speaking, for all these dangerous stored procedures, just deny execute access to public whenever you can. There are a ton of hardening guides out there provided by Microsoft and other kind of database security companies. So go check those out, use them, love them, implement them across your organization. Next up are service accounts. So once again, we talked about this on the intro. The service account runs in the background. The Windows SQL Server runs as a Windows service, and that runs with the privileges of the service account in the background. So whatever account you assign is what we're going to be able to take advantage of as an attacker, so you typically want it to be least privilege. But the big issue is that service accounts, often when we do pen tests, are configured with a local or domain admin. Local admin or local system is probably 8 out of 10 servers that we hit. Domain admin used to be about half the environments, say 5 or 6 years ago. Nowadays, SQL Server is configured as domain admin, maybe 2 out of 10, something like that. Or maybe 1 out of 10. People have definitely gotten better since PCI started pushing security out a little more aggressively. And then the second issue is that we have SQL service accounts, that someone will go out and create a domain account and then use it to run their service. They'll give it local admin rights, and then they'll use that same account to run every single app in their environment. So you might have your blog that's externally accessible, accessing a database, and that's running with the same service account that runs your banking site. And so obviously there should be some more isolation there, and it causes some risk. And we'll talk a little bit about that. So namely, shared service accounts have an inherent trust. By default, the service accounts have sysadmin rights, or that's what I've seen during the network penetration test. So you're able to actually leverage that to move between servers. Sysadmins, as we talked about, our DBAs, can impersonate the SQL Server service account without a password by using XP command shell, by using agent options for executing operating system commands like cmd exec, PowerShell, VBScript, etc. And as an attacker or developer, I mean, you could basically create your own store procedure and just import that to execute OS commands as well. So there's lots of options as a sysadmin in the database level for basically running commands as that service account, and there's very little auditing there. And then, as I mentioned before, with the XP directory function, you can force the service account to connect to you. And because public can execute that XP directory command, they can get a password, crack it, and then use it on multiple servers, which is pretty impactful. So the requirements here are you need a connection of some type. The service account needs to be configured as a local admin or a domain admin. And then you need access to one of the functions below, XP command shell, or the agent stuff I talked about, XP directory or file exists, to basically force the server to authenticate to you. So here's a really quick example of what it looks like when, say, a sysadmin decides they want to run operating system commands. They can use XP command shell, type who am I, and we can see the user, and then we can also type the net user command there with the username variable, and it shows us that we're running as a local administrator. So it's very easy to run the OS commands and then see that, suddenly an account that's supposed to only exist, the SA account, which is supposed to only exist as an SQL login within SQL Server, does have the power to actually run as an operating system account. So there's not a whole lot of isolation between those layers. So here's a quick example of how the trust relationship can be used maliciously. So an attacker can come in, throw a hole poke through the firewall from the internet, hit the web server, find an SQL injection, and then get into the database one there. And then from there, if that's a sysadmin account, and the actual SQL Server service is running on DB2 as well, we can use XP command shell, drop down to the operating system level, and then use this OSQL command, which is a native command line tool. And there's also SQL CMD, and a few others, ISQL, more like it for older versions of SQL Server. Anyways, these can all be used as SQL clients to connect to remote servers. And with that -e switch, what it's going to do is use integrated authentication. So once again, I'm running as the service account through XP command shell, and I can now query a remote database with that account and authenticate to that remote server using the -e switch without ever having to provide the password. So that's pretty impactful and very hard to detect. Another scenario that we use during pen tests is something called SMB relay. So as an attacker, we might connect to the database, and from there we'll force the database to authenticate to us. So once again, we use like XP directory function, right, to force the SQL Server service account to authenticate to us. And if it's shared between two servers, instead of cracking it, I can just forward it on from server A to server B. And if once server B validates, hey, yep, we're trusted, authentication's good, then I can start actually pushing whatever commands I want to server B, take over that server. So here is a quick video on that. This is more of kind of a lab scenario. So here I'm running a VM. It's an app called LVA, or low value application. It is running with the DB service account we can see here. And next we can see I have the application that is the front end that connects to the LVA database, and oh, this app has SQL injection. Very, very bad. So just to show you here, DB1 has been configured with the same service account. This is now server 2, let's call it. And I can go into Metasploit with a little bit of this knowledge. Start up SMB relay, or select it. I can use the SQL NTLM Stealer SQLi module we wrote a while back. So this is going to be executed through SQL injection. It's going to execute XP Directory. You have to provide the R host, which is the system that you're going to be forwarding authentication to, and you'll have to set the SMB proxy, which is actually going to be your attacker system, because this is the authentication request is going to be pushed or forced through SQL injection via that SQL injection point that we see right there. And since we're on the internal network in this scenario, this is my attacker's IP address. So like I said, we can set this to the SMB proxy. And then set the remote port, which is 80. And then show options. Make sure everything is as it should be. And then away we go. It conducts the injection, it grabs the authentication, relays it to the other server, and using the magic of Metasploit, it delivers a payload, and now we have a shell on that system that we can interact with, as we see here in a second. There we go. We're interacting with that system, DB1. All right, so hopefully that made sense. So the fix for this, there's a couple things. For systems or SQL servers that don't need to be clustered, what you can do is, or what we recommend not to do, is don't run as a local system. Don't use local or domain accounts with local administrative privileges. And if you can, use the cool virtual service accounts that Microsoft has come up with. So in the past, what we've recommended to a lot of people is if it's a standalone box that's not clustered, use network service because it has very little privilege locally and can still do what it needs to on the network. But the problem with this is other Windows services run with network service account, and so there's some inherent privilege between different registry keys and different files and folders related to other applications that SQL Server really shouldn't have access to. And so Microsoft's answer to that has been the virtual account, which is more or less a network service account with its own SID, so that it can sandbox the access controls a little bit more, which is really cool. So check that out. There's something very similar on the domain level, but I haven't spent as much time on that, so I'm not going to speak to it in depth at all. For the clustered servers, it's a requirement that you use domain accounts so that you can have that trust relationships for failover and all those other things. So recommendations here are, do make sure to use accounts that are configured with least privilege. Microsoft has some great guides as to what privileges those accounts should have on the operating system. And then don't use the same service account across servers that house unrelated applications. So once again, your blog site, that's external facing, should have an instance running with a different Windows service account than, say, your bank site. So that trust relationships we talked about earlier just isn't there. All right, let's not forget about the users, right? This is one of my favorite ones. It's one we've talked about for quite a few years. Domain users, in a few scenarios, end up with way more privilege than they need, or with some privilege, even a little privilege that they shouldn't, which can result in big bad things. Namely, SQL Server Express installed on a domain system through a series of inheritance often gives every user on the domain rights to log in. So if I'm a developer and I'm on my domain box that's been joined to Active Directory and has a computer account and all that, and I install SQL Server Express to do some quick testing, I may have unknowingly let every single user in the domain, given them the rights to log in to at least the SQL server. And depending on what service account and how the service is configured, that can mean you've now given every domain user on the domain rights to take over your operating system. So we'll talk about that. And then there's some scenarios where database administrators just don't know who in Active Directory or what roles or groups need to be added or given access to the database. And so they just use the domain users group, which means everybody. So I'll talk about the SQL Server Express issue here. Once again, we have our blue box, right, our Windows operating system, our SQL Server Express instance. And by default, the built-in users group has the rights to log in, which doesn't sound bad, right? You know, I am running this locally. I would like users to log in locally. Sure, that makes sense. The issue is that the NT Authority Authenticated Users group, which is not a group you can actually manipulate, it's kind of like a layer underneath your normal user management. It is inherently a part of users, and then the domain users are inherently a part of that. So there's this kind of chain that goes all the way through. I did talk to a few guys at Microsoft a while back, and they said, well, our users is only, the built-in users group is only added by default for SQL Express, and by default there's no listener that's enabled, so people can't connect to it remotely until you enable the listener, which is 100% true. But if you're enabling that listener, you are opening yourself up to this. So just be aware of those types of things. And to be fair, I have not tested this out in SQL Server 2014 yet, so they may have fixed it. I know they definitely upgraded some of their documentation to be a little bit more clear after the chat we had. So just something to be aware of. So the problem here, as I have kind of already seen, is that with very little privilege, like given to the public role, which is everybody once again, people can do really bad things. So as an attacker, all I need is a domain account to get into all kinds of databases. When we try out this on pen test, it almost always ends in compromise of at least one database via this escalation path. So say we have a domain user, we go to Active Directory, we get a full list of all of the databases that Active Directory knows about through service principal names. We then verify that we have connect privileges as a standard user, right? So here we're looking for databases that are SQL Express very often, or where the DBA has allowed all domain users to log in. We then use something like XP Directory to get the hash, and then once we have that, we can log in as a sysadmin. We can use functions like XP Command Shell to run as a service account, or basically take over the OS to our heart's content. So sometimes this is one step instead of two, and then from there we can take over the entire domain world, etc. So just so you know, be careful when you're rapidly deploying SQL Server in your dev environments. That's where we see it the most. So we have I built one tool for this called Get SQL Server Escalate Check Access. It will go through and grab some interesting information. You can also just use the Metasploit module that's been around forever, and actually it's much, much faster than the PowerShell module. I wrote just because of the way the threading works in Metasploit, which is pretty cool. But the PowerShell module will do a few extra things, so here's kind of a screenshot of that. It will go out, check general connectivity, and then it will give you some insight as to the IP address, the server name, and then whether or not when you connect you have sysadmin privileges, and whether or not the service account is running as a domain admin, so that you can then have a good list of targets to go after. And I also set it up so if you run the command that is shown here or in the help menu, which I've written for it, you can get this type of output where it will show a little bit even more than what you saw on the screen. So it'll show you database links and whether it's clustered or not, and what service account it's using and what privilege that has, and things like that. So can be really handy, but a little bit slow. This is a nice, easy fix. Don't provide the entire domain users group privileges to SQL servers. Make sure you're using smaller groups that should have access instead of everyone. And then don't add the built-in users group. I mean, in most cases, you're not going to need it. If you're a developer running a local installation of SQL Server Express, whatever, usually you're going to add your current user as a sysadmin anyway, so there's not a whole lot of use to have that entire group there by default. So just get rid of that. All right, this is one of my favorite categories, number 8. database link chaining, and excessive privileges. So for those of you who are not as aware, a database link is kind of like an ODBC connection between two databases. So it's a pre-configured set of credentials that allow users to connect from database A to database B without providing any additional usernames and passwords, right? So it's data sharing between servers is probably the most common use case. Sometimes it's used for light backup. Sometimes it can also be used to tie into files on the operating system, but I'm not going to go into that scenario today. Generally, we see they're configured with excessive privileges. They can be crawled with open query, and I'll get into that in a little bit. And then also, I can execute things like XP command shell via open query remotely through different links or link chains, which allows me to take over the operating system, which can be bad. Other problems here that I'm just highlighting are that you can move between a low-value database to a high-value. So I might, once again, compromise the blog site, but if there's a link out to, say, the bank site, then that's bad, right? But because of the chaining that I kind of highlighted in section 2 here, I know a lot of you might be thinking, well, no one's ever going to link the blog site to the bank site. That will never happen. And that could be true, but the blog site might link, the blog database site might link to a metrics database, and that metrics database might also link to the bank site. And so now I just need to hop through the metrics database to get to where I'm going. And I'll kind of highlight some images or scenarios in a little bit. And then that can be, this link chaining can give data access, can give OS access, and then we can combine it with the other attacks we talked about before. All right, so here's kind of the scenario I was talking about a moment ago. An attacker can come through SQL injection, get onto server 1. Server 1 might have a single link on it that's configured with least privilege, so I can move from server 1 to server 2, and now I have some access to server 2, not just data, but anything that the public role has access to. We've talked about some of those attacks. And now I can move from server 3 to server 4 if there's a link there. Once again, this could be configured with least privilege. So at this point, I'm not a sysadmin. But when I get to server 3, I see there is one more link back to server 1, and this is configured with a sysadmin. So now I can leverage that link and then execute XP command shell. And what we see attackers doing, and what we've written into some of our scripts, is PowerShell injection. So on the command line, you can actually leverage PowerShell to inject code into a process and basically get reverse shells or run whatever commands you want on the operating system. I think the original author of that code was Matt Graber, if I'm getting his last name right. Anyways, really, he does some really cool work. He's out on the internets, of course. But go check that out. Anyways, point being, multi-hops, minimal privilege equals bad. Just to reinforce these attacks with some actual statistics, from some of the work that we've done, about 50% of the web applications anyways that we've seen have at least one or more links. Usually they can be crawled, so that's a pretty high percentage when you think of how effective is this technique. It's really not that rare. It's just less known because most pen testers aren't DBAs either. Devs aren't DBAs, pen testers aren't DBAs, so we, historically, it's not been a target for a lot of people, but it's a very effective method of escalation. The next little metric I have there is the max number of hops, meaning, so here we have 12, and what this means is I or we at NetSpy have hopped through 12 individual database servers to get sysadmin or to get to the data that we were talking about. And in some cases, we're hopping between network zones. So say we start on a user LAN and there's database links between different SQL servers. Sometimes it traverses into the secure zone, which might be PCI or some other regulated data. So that's pretty powerful as well. And we're not going to see any examples of it here, but you can also go use these links between different database platforms. So you can go SQL Server to Oracle and then back into SQL Server. And we've definitely seen that too in the real world. So pretty crazy stuff. And then max number of servers crawled, 226. I think the number's higher than this, but this was maybe the last one we wrote down. So we had done a crawl and we actually hit 226 individual SQL servers, over half of which we had sysadmin rights on by the end of the crawl. So it was like a read-only crawl initially, but had we deployed our actual payloads or enabled the payload deployment, we would have had, shells on hundreds of systems if that's what we really wanted. And usually we execute it through SQL injection. So there's a bunch of tools. One thing that's worth mentioning is Antti Rauntasari, as I told you before, he has actually written the blind SQL injection and some of the other fun tweaks to this particular SQL injection module. He also wrote this PowerShell module for dumping the cache password. So when you create a link from one server to another, it saves that and encrypts it so that it can be reused later when you need to connect. And so he basically backtracked that and figured out how to do it manually. So if you're a server admin, you should be able to dump those passwords if you're curious, or you happen, if you're using it as a backup plan if you lost the passwords. So here is an example video of that attack. This is the SQL injection module. It is out in the Nullbind GitHub in the Metasploit modules section, I think. It hasn't been posted to the Rapid7 guys yet because I'm still working through some of the formatting and some of the buggy stuff on the direct one, which is actually already in their framework, but I want to clean that up before making it overly complicated for them. Anyway, so in this scenario, just like the other ones, we specify the server, we specify the type of SQL injection we want to do and say go. It goes out and starts crawling the databases I talked about before. And it's doing this blindly initially, so it's a time-based attack. In the beginning here, it extracts a server name, which is LVA. It sees there's one link, so then it starts crawling LVA to HVA, HVA being the second database, and it sees two links. The first link server that it tries to hit is the bad server, which means it's not there. So there is some error handling in this at least. And the second server is another instance on the HVA. So it's then able to hit that. You can see it fails out on the bad server. And the link from HVA to HVA name 2K5 is a sysadmin, and there we go. We've already established our first shell. We have actually, verified we are sysadmin. It also outputs some data there, as I tried to mention. So at this point, we had deploy set to false, or we had it set to false. So it wasn't actually creating shells. It was just letting us know that we could deploy shells. Now we're setting that to true, and we're going to actually go to error-based injection, which, if it's available, is much faster than blind injection. So you're going to see here it rips through it in seconds, much faster than the blind injection, and you see we're already getting reverse shells returned. We now have two interactive shells plus our nice log of information, which we show here, so the different servers, the link path, the privileges, etc. So a really effective way of quickly taking over environments. And here I'm just showing, here are the shells and the ability to interact with the operating system. Thank you, Metasploit. All right, moving on. Some lessons learned here. Don't use database links if you don't need them. We've seen them misused in a lot of environments for a lot of weird reasons I'm not going to get into here. But don't use them if you don't need them. Do configure them with least privilege, and whenever possible, inherit the privilege of your current user so that if someone's trying to hop between, it will basically take your current user context, and likely that database user is not going to have access on the remote server, so they'll get access denied. But Microsoft has some pretty good documentation, so go out there, follow their best practices. All right, number 9 is pretty intuitive, weaker default passwords. We still see, and have seen for decades now, probably since the beginning of anything requiring authentication, but we've seen the use of weakened default passwords in SQL Server. So still SA with blank passwords, still SA with password to password, and a lot of vendor account passwords. So you might get an appliance or some application that comes with SQL Server baked in. Maybe that password is hard-coded. Maybe it's something you're able to change to a web interface. But either way, you should be working with your vendors to change those because they're very well known. If I get an environment and identify a particular application, I can literally just go online, look up the default password for the database account, and then log into the associated database. So try to avoid doing that. Naturally, attackers can quickly gain access to data and servers if they can guess a password. We've already seen, with a number of privileges, what they can do, varying from the least privilege being the public role, all the way up to a sysadmin login. All of it's bad. So try to avoid that. There are tons of tools that are available out there that are free and open source, Metasploit, Hydra, SQL Ping, etc. You can even tweak Nessus, I think, and other vulnerability scanners to look for kind of standardized lists. But be careful if you're doing online dictionary attacks to accomplish this. From a fixed perspective, make sure to set strong password policies. I think you can do it manually, but it makes the most sense to actually inherit it from the domain policy. So if you have an internal password policy you want to force across the board, just enable it. I think that it's just a checkbox in SQL Server that's been there since 2005, or version 2005. Do change all your vendor passwords. Disable the SA account. When you install SQL Server, you have the ability to assign any user sysadmin or a group. And so there's no reason to have SA enabled, especially when it's targeted by so many attackers. And then finally, make sure this is heavily enforced in development environments, which is where we see it the most. Last but not least, here we have no transport encryption. So up until, I think, SQL Server 2012, SQL Server did not have encryption enabled by default on communications, aside from the authentication piece. I heard that change in 2014, but once again, I have not tested these out in 2014 yet. So that's something to definitely follow up with Microsoft on, and I will check that out in the near future. The biggest issue, which is hopefully intuitive here, is that if your data isn't encrypted going across the wire, somebody gets a man-in-the-middle position, they're going to be able to get access to that data and carve that data out. You can also do SQL injection on, live database connection. So you're essentially able to do SQL injection into clear text database connections that you have a man-in-the-middle position on without the app. So it's like SQL injection without an app, which is really interesting. There's a bunch of tools that you can use to do this either on the client or server system or on the network layer that I've listed. One project that looks really interesting and cool that also presented at AppSec this year is SQL Viking. I haven't actually used it yet, but it looks really neat, and I'll probably do a follow-up on it later. But go check it out. They're on GitHub. All right. Generally speaking, enable SSL encryption. There's lots of different things you can do with this, but there's a starting point for those of you who have had zero exposure. All right. So at a high level, I've given you some recommendations for each of these issues, but as a whole, you want to prevent unauthorized access. We want to prevent privilege escalation right after SQL injection. So enforce least privilege at all the layers I talked about. Make sure that when you're using impersonation or you do need access to kind of privileged objects that are outside of your database, that you're doing it securely, hopefully using the cert signing. And when you are doing store procedures that have dynamic SQL, just make sure you're not doing that string concatenation and make sure to parameterize your queries. And then also, even if you fix all these issues and you have a very locked down database server, it's still important to understand when you're being attacked. And so there's lots of native functionality within SQL Server that will allow you to do that I have listed there. I'm by far not an expert in this particular detective area, but these should be at least a good place for you to kind of get your feet wet and get started. So I recommend checking that out as well. So if somebody compromises your database layer, you're not going to be unaware. All right, once again, I'm Scott. Thanks everybody for listening, and hopefully you enjoyed the talk.